Let's just dive right into this explainer, guys. June 18th. It might seem like just another day on the calendar, but it's actually one of the absolute greatest dates in the entire history of mathematics. Seriously, it's wild. On this single date, across completely different centuries and continents, some incredibly brilliant minds were born who literally shaped the world we live in today. Let's meet them.
What's truly mind-blowing here is that this one specific date marks the birth years of 4 people who completely transformed the technology and society we participate in every single day. We're going to jump across time today, kind of like historical detectives, hunting down the mathematical origins of our modern world.
So let's start off with a bit of a mystery. Have you ever actually stopped to wonder how your phone's GPS always, and I mean always, manages to find the absolute fastest route to your destination? Even when you're navigating through hundreds of twisted roads and crazy intersections? How does it instantly know exactly where to go?
Well, the answer takes us all the way back to June 18, 1884, to a really remarkable guy named Charles Ernest Weatherburn. He's the first brilliant mind on our list today.
Back in the 1920s, he championed something called vector analysis. Now, in simple terms, vectors are just mathematical tools that track both direction and distance through space. He fought really hard to make this specific kind of math standard, despite facing a ton of resistance at the time. And it's a good thing he did, because today, calculating those exact directions and distances is the fundamental basis for how our modern GPS systems route our paths.
Which brings us to our first huge takeaway. Every single arrow you see on your GPS map is powered by the vector math he fought to make standard. So yeah, every time you open up that map app on your phone, you are literally relying on his 19th century persistence. Pretty cool, right?
Okay, still on June 18th, but let's jump 25 years forward in time. We're heading over to Germany to solve a completely different kind of mystery.
Seriously, think about this for a second. How do engineers actually design the smooth, massive metal bodies of modern airplanes and cruise ships so they just glide perfectly without any resistance from the water or the air? It's not magic, it's math. And the math behind it goes back to June 18, 1909, with a guy named Feodor Theilheimer. He was a brilliant mathematician who had to escape Germany in the 1930s, eventually bringing his incredible talents over to the U.S. Department of Defense.
Now, before he came along, engineers had this incredibly slow, clunky, just tedious process of drawing the curves of ships completely by hand, using physical weights and rulers. I mean, imagine doing that. He completely revolutionized that process by replacing it with smooth, high-speed, computer-calculated mathematical curves. These are called spline functions. They're essentially piecewise formulas that link together to create these continuous, totally flawless shapes. He literally wrote the code that lets computers draw perfect aerodynamic bodies. It's just an amazing realization when you think about it. The smooth curves of today's planes and ships are secretly written in his mathematical code. Every time we look at the sleek wing of an airplane or the massive hull of a ship, we are quite literally seeing his beautiful equations brought to life in physical form. All right, moving right along. Same date, but just 6 years later. We're looking at a different country, a completely different kind of struggle, and honestly, an even bigger idea. Let's keep going.
Imagine the absolute frustration, the sheer anger, if someone looked you right in the eye and said you simply weren't allowed to be brilliant at what you loved most, just because of who you are. How do you even begin to prove them wrong?
For that answer, we look back to June 18, 1915, and an incredible woman named Alice Turner Schafer. When she was just a young student, her high school headmaster literally told her, to her face, that mathematics is not for girls. He even flat out refused to write her a recommendation letter to study math at the university level. Just wow. But you know what? She completely shattered those barriers. She went on to master the incredibly complex world of abstract algebra. We're talking about studying deep mathematical structures and rules here, not just traditional numbers. She defied severe discrimination at literally every single level of her education. And she didn't just become a brilliant professor, she became a founding member of the Association for Women in Mathematics, actively fighting to guarantee that everyone, absolutely regardless of gender, gets a seat at the table.
Her whole legacy really just boils down to this. She didn't just solve complex equations, she solved the equation for equality in mathematics. She took all that boundless energy and used it to make sure our math classrooms today are fair, open, and welcoming to all of us. Truly a game changer.
So one single date, but so many incredible stories, right? Well, let's make our final jump on the timeline today.
all the way to the year 1932.
We all know computers are fantastic at basic addition and crunching massive amounts of numbers. But how on earth did we ever teach them to understand deep, abstract mathematical structures and, find those hidden patterns? That massive breakthrough belongs to June 18, 1932, and a brilliant man named Joachim Neubüser. This is the guy who completely revolutionized how machines actually think about complex math.
He essentially taught computers an entirely new language called computational group theory. He spent years building this absolutely incredible software system called GAP. It allowed computers to finally study discrete mathematics, which is basically math dealing with distinct, separated values and logic. It's the perfect foundation for programming. But here's the absolute best part. He fiercely protected this massive tool, making absolutely sure it remained completely free and open source for literally anyone in the world to use.
I think this perfectly captures the true spirit of mathematics. He gave computers the power to see mathematical patterns, and then he just turned around and gave that immense power to the world for free. He really believed that sharing knowledge freely is the only way the whole world can advance together.
So, looking back at our timeline now, it's just absolutely amazing to see these four brilliant minds side by side. I mean, what actually connects Charles, Feodor, Alice, and Joachim? It's this. Every single person we met today, across totally different centuries and countries, they all basically asked the exact same question. What is the pattern hiding inside the chaos? And because they asked that, because they did the hard work, our world today has advanced GPS, sleek planes, fair classrooms, and open source computing. Because they dared to ask those huge questions, we get to enjoy the incredible technology of today, which kind of leaves me wondering, what hidden patterns in our world will your generation discover next? What big mysteries will you be the ones to solve? Thanks so much for joining me on this explainer, guys, and keep looking for those patterns around you.